Hello Brain Shakers, welcome to the Brain Shakers Academy. Brave Alice is here. Now in today's session we're going to be looking at the conduction system of the heart under the main branch of electrocardiophysiology, or basically how an action potential is generated within the heart and then helps the heart to contract at the same time, or to contract as a sensation. That means that the atrium's contracting at the same time and the ventricles contracting at the same time. So all that is facilitated by the conduction system. Now let's quickly dive into it and understand what it is all about. Okay, so I have a diagram here with me that is going to help us understand the conduction system of the heart. Now, the heart itself has structures within it that have the capacity to generate an action potential. Now, an action potential basically is more of an electrical charge creation that is then generated and passed to all these other structures in order for them to then be able to stimulate the cardiomyocytes, which are basically the muscle layers that are there within the structure of the heart, so that they can then be able to contract and generate that heartbeat that we obviously listen to. Now, there are structures within the heart that will help us achieve that heartbeat, and these structures are also responsible in making sure that the heart then gives you what is referred to as a cardiac cycle that you will be able to interpret, and it will be able to guide you on whether this particular patient that you have or this particular person that you are investigating has a particular abnormality. Now, these structures, we have this particular structure that we have here, which is called the sinoatrial node. So you have a node here which is referred to as the sinoatrial node. Now, the sinoatrial node is referred to as the pacemaker. Why? Because it is the node that has the primary capacity of generating that action potential. So this is what begins the heartbeat. So it has a specialized type of cells, which are cardiomyocytes, that have the capacity to then excite themselves. So they have a property that we call self-excitation. So the sinoatrial node doesn't have to wait for innervation from anywhere for it to be able to start or generate that action potential. So the heart still is controlled and is still given innervation from the central nervous system through the parasympathetic and the sympathetic nervous system, but the sinoatrial node has the capacity to excite itself. The cells within that node have the capacity to excite themselves, and then they generate an action potential. And when they generate that action potential, the action potential is just going to stimulate other structures also that will later stimulate the other structures, or stimulate the cardiomyocytes or the muscle layer within the heart, so that it can begin to perform its function of pumping. Now, if you look at this particular location, you find that the sinoatrial node is in an area that we refer to as the crista terminalis. Okay, so it is in an area that we refer to as the crista terminalis. This is just basically closer to the opening of the superior vena cava. So as you find it here, when it has generated that action potential, it passes the action potential to the left atrium, because the left atrium does not contain any sinoatrial node. So the same sinoatrial node that you find located around the crista terminalis, you will find that it has a branch that goes to the left atrium, and it has branches within the right atrium that will then send that action potential to another node around this area. We will come back to this node. So we're still around the sinoatrial node. It is sending an impulse impulse to the left atrium, and as it sends an impulse to the left atrium, it is sending this impulse so that both atriums, the left and the right atrium, will then contract at the same time. So the heart contracts as a syncytium, contracts together, meaning that the atria will have to contract at the same time. The ventricles will also have to contract at the same time. So this branch is what we refer to as a Bachmann's branch. Okay, so this is a Bachmann's branch. It is a branch emanating from the sinoatrial node to the left part of the heart, which is the left atrium, so that when they then contract, they contract at the same time. Now, how are they able to contract within the same time when the action potential is generated within one side and still has to travel to the other side? So they possess what is referred to as gap junctions. So the cells within the heart possess what we refer to as gap junctions. So the gap junctions now are the ones that allow for the fast and rapid transmission of those action potentials, so that there is no delay in the left atrium as well contracting at the same time as the right atrium. Now, once the action potential has then been generated, it is passed to the other node here. Now, this node falls around the area called the atrioventricular, meaning almost in between the atria region and the ventricular region, and it is often referred to as the atrioventricular node or the AV node. So this is sinoatrial node, also abbreviated as the SA node, and this one is what we are going to refer to as the atrioventricular node or the AV node. Okay, now once the action potential has been generated here, it is then passed to the AV node. So the AV node has the capacity to now transmit it to the rest of the part of the heart, which is down to the ventricles. Now, the sinoatrial node and the atrioventricular node play a key role in making sure that that transmission is going to generate that cardiac cycle that you are going to see when you do an ECG. So the atrioventricular node gives you a delay between the transmission from the SA node to the AV node. There's usually a delay of about 40 milliseconds. Okay, there's usually a delay of about 40 milliseconds, and this is done on purpose because there has to be complete emptying of the atria, so that when the ventricles then contract, the atria would have completely emptied their blood into the ventricles, and then now the ventricles can begin to do what? To contract and then send or pump that blood up there. Now, this atrioventricular node or the AV node is found around a triangle that we call the Cox triangle. Okay, so there is a region here that we call the Cox triangle. Okay, so the Cox triangle is basically just an atrioventricular triangle around here, and so from the atrioventricular node, then you have a portion here that we call the bundle of His, or the bundle of His. Now, the bundle of His is just a continuation of the AV node to a region then where it gives two branches, meaning that it will reach a region where it will bifurcate and give you the left bundle branch. So this one is now going to be called the left bundle branch, and this one will be called the right bundle branch. This is what we then referred to as the bundle of His. Okay, the bundle of His. So when the action potential has then been generated from the sinoatrial node, it is then passed to the atrioventricular node, passes through the bundle of His, and then we'll get to the left bundle branch and then the right bundle branch. And where you have all these branches of all those tributaries that are emanating from the branches, these are what we are going to call the Purkinje fibers. Okay, so you have fibers emanating from those branches, and we're calling them the Purkinje fibers. So that once that action potential then is passed into the branches and then gets to the rest of the cardiomyocytes at the same time through those other branches that emanate from the main branches here, and then the ventricles will be forced then to contract at the same time. So basically this is what happens for that during the electrical conduction system within the heart. So the sinoatrial node, or the SA node, is what is referred to as the primary pacemaker and the originator of that heartbeat. But then this atrioventricular node also has the capacity to generate, okay, that action potential. But then the sinoatrial node conducts or generates an action potential at a faster rate because it has cells that are more specialized to perform that particular function at a faster rate as compared to what is going to be created by the atrioventricular node. So the atrioventricular node, or the AV node, will still be able to generate an action potential because it also possesses those cells that have the characteristic of self-excitation. And also with the AV node, you will find that the AV node will only come in as a secondary pacemaker when the sinoatrial node is unable to actually generate or give rise to that action potential. So this is the way the electrical current or the action potential is then generated within the heart and passed to the rest of the heart, so that the heart can then pump blood at in a manner that is well coordinated. So once the blood is pumped out of the heart, or during that conduction system, it is going to give you a cardiac cycle. It will give you something that will look like this. So you have a structure like that, and then you have all those portions, and sometimes it will give you even a U-wave. So these are some of the things that you're going to see when you're looking at this is basically what you will see on an electrocardiogram, or when you look at an ECG or an EKG. So do look out also for a video where I look at the Enthoven's triangle, or the factors that we look at when we're looking at basically an ECG or an electrocardiogram. So this is emanating from the conduction system that is happening within the heart. So basically that is what happens within the conduction system of the heart. It's just the structures that are there. That is the sinoatrial node being the primary pacemaker, generating that action potential and passing it over to the atrioventricular node, which then later passes it over to the bundle of His, then to the bundle branches, and then it will come through to the Purkinje fibers, and then the atriums and the ventricles will contract at the same time. The atriums contracting at the same time and the ventricles then contracting at the same time, with the atrioventricular node obviously controlling and causing a little bit of a delay so that there is complete emptying of the atrium. Now, if you found this video particularly helpful in trying to understand the conduction system, don't hesitate to give me thumbs up, drop me comments and questions in the comment section. I would like to hear what you think, and please be a follower and also follow my YouTube channel, which is the Brain Shakers Academy, and I will see you in the next one. Thank you so much for watching.